What if I told you everything you thought you knew about finding alien life is wrong? That scientists have been making a massive mistake for decades. For years, we've been taught that to find alien life, we need to look for planets in the habitable zone, that perfect distance from a star where water can exist as a liquid. But here's the shocking truth. We've been thinking about this all wrong. The habitable zone isn't a fixed ring around every star. It's a dynamic, complex concept that's way more fascinating than you've been led to believe. Let me break this down for you. The Goldilocks zone, as it's often called, is based on a simple idea. Not too hot, not too cold, but just right, like Goldilocks and her porridge. But here's where it gets interesting. The size and location of this zone changes dramatically depending on the type of star. Around a massive, hot blue star, the habitable zone is huge and far out. Around a small, cool red dwarf, it's tiny and close in. And this has massive implications for the search for life. Scientists have discovered over 5,000 exoplanets so far, and many of them are in their star's habitable zone. But here's the problem. Being in the habitable zone doesn't automatically make a planet livable. There are so many other factors that could make or break the possibility of life. The planet's atmosphere, for starters. A thick atmosphere like Venus creates a runaway greenhouse effect, turning a potentially habitable world into a hellscape. A thin atmosphere like Mars can't hold on to heat or protect from radiation. Then there's the planet's geology. Does it have plate tectonics to recycle nutrients? A magnetic field to protect from solar radiation? The right mix of elements? And here's something that will blow your mind. We're discovering that life might exist outside what we traditionally consider the habitable zone. Look at the moons in our own solar system. Europa, orbiting Jupiter, is frozen solid on the surface, but has a vast ocean of liquid water beneath the ice, heated by tidal forces from Jupiter's gravity. Enceladus, a tiny moon of Saturn, has geysers shooting water into space. These worlds are far outside the sun's habitable zone, yet they might harbor life. This changes everything. It means we need to expand our search beyond just planets in the Goldilocks zone. We need to look at moons, at planets with unusual orbits, at systems we never considered before. The James Webb Space Telescope is already revolutionizing this search. It can analyze the atmospheres of distant worlds, looking for biosignatures, chemical signs that might indicate life. But here's the real kicker. We might be missing the most obvious place to look. What if life doesn't need water at all? What if there are completely different biochemistries out there? Life that uses liquid methane instead of water, or thrives in conditions we can't even imagine. The truth is, the habitable zone concept is just our starting point. It's based on the only life we know, life on Earth. But the universe is vast and creative beyond our wildest dreams. As we discover more exoplanets, we're learning that the rules aren't as simple as we thought. Some planets orbit two stars instead of one. Some have wild, elliptical orbits that take them in and out of the habitable zone. Some might be tidally locked, with one side always facing their star. Each of these scenarios could potentially support life in ways we're only beginning to understand. The search for alien life is entering its most exciting phase yet. With new telescopes and technologies, we're on the verge of discoveries that could rewrite everything we know about life in the universe. But to make these discoveries, we need to think bigger than the traditional habitable zone. We need to embrace the complexity and diversity of the cosmos. Because if there's one thing the universe has shown us, it's that life finds a way, often in places we never expected. What do you think? Are we too focused on the habitable zone, or is it still our best bet for finding life? Drop your thoughts in the comments below.